Cool. All right. So I want to start off today talking about SIG Network test flakes. Dan is here to talk to us a bit about that.
Hey everyone, how's it going? We're just under 2 weeks away from the release, and I'm just here to give an update on the current status of flakes. It looks like there's just under 50 flakes currently in the milestone for SIG Network. We're doing things a little differently this release, where anything that is in the milestone is considered blocking for the release. So the new system will be to remove things from the milestone that will make it not blocking for the release. So if everyone could just go through and triage these issues, and just if it's incorrectly labeled for the SIG, please just move it to the other SIG to another label, and not blocking removed from the milestone. And if you need any assistance around test infrastructure or anything around escalation, feel free to ping me or anyone else on the release team. Is there any questions around that?
How do you want people to reach out to you, Dan?
You can at release team. It's like Kubernetes team.
Cool. Great. So, do we have any volunteers to go through this list? 50 sounds like quite a few.
Yeah, I'm going to try to go through at least a couple a day and see what I get.
Yeah, I will also try to do a few a day. If we get some more hands looking at that, that would be great.
I could take a look too. The one problem that I've had with flakes is attempting to replicate them. Unless you really prod at the test infrastructure, sometimes it's difficult to replicate. I don't know if anyone has any pro tips around that.
Nothing for me.
Probably be a good question for Dan, actually, right?
Yeah, so are you trying to sort of get an idea of the frequency of flakes? Is that what you're asking?
Well, if we identify what a probable cause is, how could we test if we've been able to fix that or isolate it or something like that? For example, if it's getting run on GCE, how are we able to make sure the flake is gone yeah.
So the testing environment, the testing runner can be run independently from the testing system, but there definitely are caveats to the testing system that are very hard to recreate as an environment, to be completely honest. So it is fairly difficult unless you actually run the full runner, where it brings up a cluster and provisions it for you and then runs a test for you.
So I can imagine that out of this 48 flakes, we might be able to find the cause of a couple of those. Hopefully many, but fix them. So, what if we're basically unable to cause, 10 flakes or something like that? What happens to those in 2 weeks?
Yeah, totally. So just a judgment call needs to be made around if this is flaky enough to jeopardize the release. Historically, that has been where it's been flaking. Complete blocking would be like if it was flaking under every 4 tests it would have flaked. We're sort of leaving it up to the SIGs to decide what is blocking for them. But that's sort of the guideline in general. Just if it's under 4, then that's pretty significant.
So shall we just start trying to knock these down, and then if we have further questions, reach out to you, Dan?
Yeah, I think that makes sense. Just from looking at other SIGs, I think a lot of these you should just be able to clear out just based on how infrequent they are. Most of these are just going to be, and you can sort of get a rough idea by the P series priority labels that the bot gives. P1s are going to be more frequent, and then lower or higher Ps will be less frequent. But most of these, I think you'll probably be able to knock out half of them based on frequency, at least.
So what does it mean for frequency if there are issues that have not been tagged with a priority?
So the best way to sort of investigate that is to use TestGrid. I can put a link to that into the meeting minutes, but basically just going through figuring out which suites that test is in, and then looking at the history for that test run. I'll put a link to TestGrid right now.
Okay, that would be great.
Cool. Thanks a lot, Dan, for coming on and telling us about that.
Yeah, absolutely. Thank you.
So the next thing I wanted to talk about just quickly at the beginning was CNI. So people hadn't noticed there was a CNI release 0.5.0, which is a long time in the coming. That came out yesterday, was it?
Yep, yesterday, Wednesday.
So I think there are just a couple of things related to this. One, are we still intending on putting this into Kubernetes 1.6?
Yeah, so Casey Calandrello, I think, has an open PR for that to do some of the revendor. I think it'd be good to get in. It's not obviously strictly necessary, but this release would be a base for stuff that a lot of people here want to do. For example, multiple interfaces inside a pod, multiple IP addresses inside a pod, some stuff around hypervisor-based stuff. As well, and I'm trying to think of some of the other things. But all in all, I think it's a pretty big release for CNI, and so it should enable most of the plugin writers that are part of the SIG to do some of the things we've been blocking on for a while. The other thing to mention with the release is that it attempts to be backwards compatible. So unless you actually change something in your configuration, even though you've updated the code to CNI 0.5, everything should still work. You have to explicitly opt in. Do this. But this also means that on the Kubernetes side, Kubernetes can opt into these features, and then it's Kubernetes' responsibility to make sure that it doesn't send your plugin a format of information that your plugin does not expect. So, I mean, short version, plugin writers shouldn't have to do anything, but there should be some capabilities in the near future for plugin writers if they want to opt into those.
Cool. Thanks, Dan. And I think the only other CNI related thing is you may have seen it go by on the mailing list, but there is a community sync for next Wednesday, I believe. If people are interested, that'll be the first of its kind. So check the mailing list for that invite. So we've got a bunch of stuff on the agenda here. I was planning on just going through in the order they're listed from now on, unless anybody has an urgent reason that they need to go first. So let's start with the load balancer claim proposal. Link to that is in the doc. Does anybody want to talk about that?
Our team has submitted this proposal. The general purpose is that currently Kubernetes just deployment one L7 load balancer in a cluster to serve all the ingress connections, but a single L7 load balancer may have some bandwidth or connection number limitations. So there may be some need that user want to create multiple L7 load balancers and specify which load balancer to serve which ingress. And in multi-tenant case, some tenant may want to use the own dedicated load balancer and do not want to share this load balancer with other namespace. So mechanism need to add to Kubernetes to allow the user to create L7 load balancer dynamically. So this is generally the load balance claim proposal wants to do.
Great, thanks for the summary. Has anybody on the call read through the proposal yet? I know that I haven't. I saw it go by, but it's on my list to read still.
I read it. It's Brian here. I guess, I mean, it seemed plausible. I made a few just minor typo comments on the PR. The concept seemed plausible, but I have no real familiarity with working with those kind of things. So I couldn't really tell you at that level. Tim Hockin had some interesting comments in the issue about what's a class and what's a claim. It seemed that was valid. Although that didn't seem to invalidate the idea, it just seemed to be like a clarity of terminology thing.
Yeah, so it sounds like at the moment, should probably continue discussion on the proposal and make sure that the relevant interested parties are reading that.
I read through it, and I think it's a good idea. I think the idea of a claim could make sense for the scenarios that you described. But also part of me believes that a load balancer should be an infinite resource that, you know, if you're thinking about a multi-tenant environment, why would a tenant ever be denied a load balancer? So that sort of conflicts with the idea of reserving something or laying a claim on it. And there could be other, you know, maybe types of load balancers that could provide the isolation or characteristics that you're describing. Not saying I'm not critical of your proposal, but it occurs to me that there's so many different scenarios for load balancing deployments, inside, outside, egress. It's just mind-boggling. Are we ready to sort of formalize a particular approach? And I just leave that as an open question. Maybe we are. I don't know.
Yeah, it's a good question, and I think you know, historically we have generally not touched on L7 stuff a whole lot in this group, as we've talked about in the past. So I guess it's just a call to action for people to get their L7 friends look at this.
Yeah, I think that may need a lot of things to sort out. So just how to say, just put the proposal and call for more feedback from community.
So I have a question for you. So getting back to that point of a sort of an inexhaustible supply of load balancers, I mean, I know that NetScaler and F5 devices can easily handle hundreds of VIPs. And that doesn't, I mean, you know, on a massive scale, that's not a big number. But if you're going to deploy this, you know, 100 or a couple hundred per box doesn't seem like a small number to me. So is that a scenario that, or is that a method that you've thought about? Is that the way you're doing it today?
Sorry.
Well, I know you can configure. My point is very simply, you can configure, you know, a very large number of VIPs on a physical load balancing appliance these days. And have you ever run up against the case where you needed to reserve it with a claim?
If I understand correctly, you mean some physical load balancer can has a very high performance, so that it's enough to deployment one load balancer in a cluster?
Yeah, that's basically my question. Have you ever exhausted the capacity of a load balancing appliance?
And maybe some use case that in multi-tenant environment that a user pay the money to you, and he want itself exclusively use the load balancer. He don't want to share this load balance to others like this.
Yeah, I understand that. So that's a cloud provisioning service or example. I can see that easily. Okay, so I mean that's one scenario, but okay.
Okay, so if you have more questions, you could just comment on GitHub.
Okay.
Thank you.
Cool. Thanks, guys. The next issue on the agenda is also for you guys about the bare metal ingress HA.
Yeah, I don't. That if currently the bare metal ingress HA is put a IPVS cluster in front of Nginx ingress controller. So a client's request first reach the IPVS cluster, and the IPVS cluster forward the request to Nginx ingress controller, and the ingress controller then forward the request to the backend pod. Our team has used a Kubernetes sidecar deployment deploy with the Nginx ingress controller and bind a VIP to the host's interface. So request could reach the Nginx ingress controller directly and send to the backend pod. And the first master branch has implement leader election in the Nginx ingress controller. So there is another approach that does not use Kubernetes, but the Nginx ingress controller just bind a VIP to its interface by itself. So I think this is another solution for HA. Did I express myself clearly?
Yeah, I think my question would be what what is do you just want review on that issue, feedback from the community at this point? What is it that you'd like from the members of the SIG? Did I mute myself?
To just summarize what we did previously, we haven't reached the point yet to standardize the APIs for load balancer or the Kubernetes. We just want to show the community that we are doing this, and we want to make a way for people to express interest in the network resource, because we already have the PV and PVC concept in Kubernetes. And so we think, and we already have some requirements from our customers that they want to share the or developer or their customers. So that's basically the goal. We haven't reached the point where we can show some demos to the community. The point is, we think this could be we can do to the to Kubernetes. And the network resource, this ingress or a lot of bands, although we're still refining it. And our next step would be to do the recycling stuff of the load balancer resource, and then we want to find what kind of network resource we want to define, like the bandwidth and IOPS. Then we will do something like scheduling for the load balancer, so people can claim interest of how many IOPS or how many bandwidth they want, and we want to find a way to enforce that in the load balancer. For the Kubernetes stuff, it's just the backend. We want to show to the community that we can do this with Kubernetes. And for just like Chris mentioned, we also can use F5 or some hardware load balancer to do this. This is just the first step of the load balancer controller, and to see if this is we want to have some feedback from the community to see if this is the right direction or it's not. So not about the details of the balancer controller, just if this is the right direction or we just take the wrong way.
Cool. Well, yeah, thanks for sharing. I put the link, or you put the links in the doc. So if people are interested in reviewing this, please go and provide feedback. The next topic on the list is multiple networks. Is Joji on the call?
Hello.
Hi.
Yay, sorry, I was on mute. Okay, so I think we basically have like two high-level issues, I think, that needs resolution on the multiple network side of things. I think they are probably related, is what I'm thinking. I think everything is boiling down to how we define. I think you hit on the point in your earlier comment. So how do we define the role of an API user? So it sounds like we are only thinking about the developer, but when we create a network object, are we expecting the developers to create those network objects? I think that's the first thing that we need to agree on. Or are we expecting like a more granular user? I mean, it's probably not only the developers who is going to be creating all the API objects. I can see, the pods and the or application objects are mostly created by the developers, but things like network probably is going to be created by a developer / ops person.
I think it also depends on what kind of hardware and capability the cluster has, because if network creation is cheap with whatever plugin is being used, then maybe you do want to allow developers to set up their own custom networks and whatnot. But, if it requires special hardware on each node, or if network creation is expensive and consumes too many resources, then you might want to restrict that to an administrator.
Okay, no, so I'm not speaking mainly from the perspective of cost here. I think it's mostly from workflow perspective. I mean, let's leave the cost part of it aside. I think that will be very implementation specific. But in a general sense, from a workflow perspective, what is the expectation?
Well, I'm kind of interested in taking a step back. I know I raised some questions on the use cases in the doc, and I got some responses just before the meeting. I haven't had a chance to read over those yet. But I'd like the use cases presented to kind of capture this from a user's
So
level.
Casey, I have summarized the use cases. I think if you look at them at the beginning, I have summarized some of the use cases. I think the rest of the use cases kind of fits into that use case at the top that I have summarized. Mainly boils down to disjoint networks. There are use cases where the networks are considered disjoint. In other words, you can't reach both the networks through the same interface. That's the whole point of having multiple interfaces inside the pod. If all of them were reachable through the same interface, strictly speaking, there is no need for multiple interfaces, if you ask me.
That's not entirely true, though, because I think with different network capabilities, even if you could reach a particular network through like a 1 gig interface, and you also had a 10 gig interface connected to that same network, you might want to dedicate that 10 gig interface to specific application.
Yeah, but that's up to the networking infrastructure to take care of, though. I mean, you can have the same network plugin connected to 2 different uplinks, and then you can use just plain forwarding rules or policy to decide which way you wanted to go. I don't think that's the issue we are addressing here. I think the issue we are addressing is strictly disjoint networks.
Okay.
There are many reasons why you would want something like this in a deployment in the use cases. A lot of times it's because of operational security, because you don't want this particular network accessible through the data or main data path. For example, you want to keep your management. If you're deploying a multi-tenant application using Kubernetes, you might want to keep your infrastructure network separate from the tenant network. You might be using it for some sort of provisioning or control like that. There are applications like that, especially involving NFC. The other use cases where you want to keep storage completely separate from your other network traffic. So, I think the fundamental requirement is when these networks are strictly disjoint.
I'm still a little bit fuzzy on those last things you said, and they're just me being a little slow. So when you say fundament, like these disjoint storage and data networks, for example, are you referring to like host networks? So the host has multiple interfaces, and you want to bind a pod directly to one of those?
That would be one use case. I mean, I think in order to have disjoint networks, yes, the host needs to have multiple physical interfaces. I think if the host ultimately only has a single NIC, I don't think it's possible to have disjoint networks, at least at the virtual level. I mean, physically, it may be a single NIC, but at least virtually, it needs to have like 2 different NICs in order for them to be disjoint. But the idea is, think of it this way. There are like 2 parallel networks, okay, and they are not connected to each other. And the pod needs to have a presence on both of them in order for it to function or deliver its functionality. It's slightly different from, a mainstream application. But,
the pod needs to have a presence on both of them, but I'm trying to, so if that's the high level requirement, does that necessarily mean a pod needs 2 virtual NICs itself?
2 interfaces, yeah. It needs to have 2 interfaces because an interface can only belong to one network.
Sure.
I would say that's not strictly true, but you would have to mix traffic and use a vSwitch or something like that. But that kind of runs counter to some of the use cases that you've been talking about at the top with respect to security and traffic isolation, of course.
Exactly.
Actually, I'm not sure it does, because if these are on the host and I've got virtual interfaces on a container that are connecting to those 2 different physical interfaces, they're doing that through some kind of shared connectivity within the underlying host OS, right? It's either going to be a bridge or it's going to be a routed interface. It's going to be something. So at some point, I am mixing this traffic anyway in the underlying kernel.
Not necessarily. I mean, you're mixing in the underlying kernel, yes, but you might not be mixing the storage traffic and the general pod traffic. You could, for example, have a vSwitch or a bridge dedicated to each of the physical NICs on the card and then attach certain virtual NICs to those specific bridges. So you wouldn't be mixing any of the storage and the general network traffic for a pod.
You could, yes, you could. I'm not sure how much of a win that actually is because it's still resources on the host and it's still in the host namespace, right? So I'm not sure. It is a
It's not. No, it is not in the host namespace. I think that's a key distinction. It doesn't have to be in the host namespace.
So you're going to bind a physical interface directly into the pod's namespace. Is that what you're asking?
No, like Dan was pointing out, it could be each of the physical interfaces could be attached to a bridge or a switch.
Right, but that's still in the host namespace, right? That's still in the underlying root namespace.
It doesn't have to be.
But you could also have interfaces like SRIOB or stuff like that that would go only, like it would appear as another interface. So imagine, I don't know, if you would have some NFBKs and you would want some SRIOB inside the pod, and you would have the normal networking for the control, and the other one is for the data. So you would legitimately have two interfaces there, and who says SRIOB says some DPDK cases and so on.
I think, unfortunately, the matrix here is an M-to-N of interfaces and IP addresses that we kind of need to deal with.
Yeah, I don't know if people saw it. I sent a message. I didn't have time to send it to the mailing list. I put it here on the group chat. That it expands on Dan's proposal so that apart from if you have multiple networks, that the CNI plugin can find it in several places.
Okay, so I have one request. So if you have ideas on how to do this, I would request that we all consolidate, because we already have a document tracking and we are consolidating all the ideas and proposals there.
Yeah.
So if you can bring it there. And one other thing I wanted to point out is it's not strictly CNI. So one of the things that Tim told me right at the outset is that we cannot assume that it's going to be CNI all the time. So we have to be independent of CNI. So that's one other thing
that's fine. Okay. That's fine. So the proposal actually it goes a bit along those lines, because what it does is it keeps the network object in the API not having knowledge about what is the nature of that network, because you can put it there as metadata, but it doesn't know about specific IPv4, IPv6. It could be a description of hardware or whatever.
So we are discussing, what can go into the networking, the network object, and all those things. I mean, we all have like different different ideas on that. So we'll arrive at a conclusion. But I just wanted to make sure that we are all on the same page from a workflow perspective, because it appears that we are not. So let's get there first, and then I think we could consolidate, your ideas with what we already have. There is already like more than a dozen people already contributed to this proposal that we're working with. So viewers can be easily added to that. Does that make sense? So then it'll be great if we can at least arrive at a conclusion on the workflow side of things, and how configurable things need, because it's easy enough to take an approach where all we have from a network object perspective is just a handle, and everything else gets configured out of band. So that will go back to my original question.
Before we leave this topic, I've sort of been struggling myself to find a scenario where an individual pod needed access to two external networks. And I understand, I don't want to discuss that, but let me get to my question in a second here. I understand the use case for separate networks and not mixing traffic. I get all that. And I believe everything you said. But my question is simply, if there are two interfaces on a pod that are attached to two different networks, how do you apply network policy to that?
Okay, yes, so that's a good question. So they will have their own separate network policy, right? I mean, those are separate networks, and obviously it'll have associated network policy with each of those.
Well, I meant enforce it. How do you enforce it? Is my point. How do you enforce it if they're both getting to the pod is really the nub?
So it's the network plugin that is attached to those interfaces is responsible for making sure that those policies are enforced, right? Does it?
Yeah. Oh, okay. And I think you're right. I think that's workable. Yeah.
So I don't think there is any direct impact on network policy as such.
Yeah, I think you're right. After a moment or two to think about it, I think you're right.
Okay. Okay. So now getting back to the workflow. So can we get some ideas on that front? So do people think that the network needs to be just a handle and everything else needs to be configured completely outside of Kubernetes, or do we think there needs to be some configurability from a Kubernetes side of things?
I mean, I guess I'm just not seeing how. I do see some advantages to having configuration within Kubernetes, but if we're not assuming a specific network plugin and a specific plugin driver, e.g. CNI or Docker or whatever, I don't see how Kubernetes can be of much use here other than basically an envelope. You write some plugin specific configuration and you wrap that up in some kind of thing that's opaque to Kubernetes and it sends it through because, yeah, maybe you could send in IPs and routes, but it's not the case that all plugins are going to be able to work with that or be able to provide the capabilities that Kubernetes would expect.
Right. So I'm not thinking more in terms of like envelope. I'm thinking more in terms of things that might have implications to Kubernetes itself. So for example, the primary interface, I mean, so we have a implicit way of determining the primary interface right now, but can we determine everything implicitly like that? Or do we need something explicit? So for example, one of the things that came up early in the discussion is the routing. I think that's where a lot of this discussion started, right? So the question really is, should Kubernetes have any knowledge of this, or it has to be completely in the network plugin? So the situation is when you have disjoint networks like we discussed, it is not possible to configure the routing entirely in one of those networks. So potentially the two networks, they could be in the same, implemented by the same plugin, but it's also possible that they're implemented by different plugins, right? So if you're covering the most general scenario, I think that routing actually belongs in the pod. I think we all agree that it belongs in the pod because that's where finally it's going to reside. But the question really is, does that fit into our workflow? If it does not fit into our workflow, then what
belongs in the pod?
I'm sorry.
I missed that last sentence.
So if you have two disjoint networks, right? You're potentially talking about routing from the pod, because the pod has to make a decision where it needs to send a packet. Because I have two network interfaces and I have an IP packet to deliver. It needs to decide which of those two interfaces I need to deliver it to.
The question is which network gets the default route inside the pod, right?
It's not necessarily the default route. Right. I think that, yeah, it's like the route. I mean, the default route is like, default route is more like a specific case. I think that really the question is, which is the route, right? So that decision has to be made by the pod, and I think that's what I was referring to. Now the question is, you can take different vehicles to get it there. So if you want to be very, very generic, like to support different networks supported by different plugins, I think the only way to coordinate this is from the pod. Or you need some kind of a controller that can coordinate across network plugins.
By pod, do you mean the pod specification? Is that?
I did not necessarily say pod specification yet. I said the pod.
Would it be sufficient for now to just, I think as you proposed in the document, indicate which network plugin is the primary plugin? Or were you intending that to be only for default routes and routing?
So that's what. So we can easily take an approach that, the primary network is the default route, and all of the other networks, they only deal with directly connected endpoints. Okay, so if it's directly connected, then you don't need an explicit route. So you have directly connected routes and you have this default route. We could leave it at that. I was going to leave it at that, but then Tim pointed out that, and we don't want to revisit this in the near future. Somebody will come up with a use case where, this needs to be more generic, more general, and that's why we are trying to solve this in a more generic way. Otherwise, it's easy enough to cover a lot of the use cases. It may be sufficient if we just say we deal with all the secondary networks. They will just deal with directly connected traffic, and the primary network will be the default route. We could say that, and we could leave it at that.
So, quick question on that. So when you're talking about routing here, you're saying, okay, so you're saying that, so imagine a pod has two separate network interfaces, virtual or whatever, it doesn't matter. Obviously, if you're attempting to reach a resource that is directly on that IP range that interface has, that's fine. The kernel knows exactly what to do.
Exactly.
But you're saying that if you want to reach an IP block that is not locally connected or not one of the subnets of those interfaces, how do you pick which interface that is, right?
Exactly. So it is possible that somebody could use this beyond the directly connected network, right? I mean, you can have two parallel networks that are routed, right?
So
it doesn't have to be just L2 adjacent.
Could that be the responsibility of the network plugin that configures that network to know which resources should be reached over it? At least as a first cut?
That's exactly what I was going to say to him.
It could be, but if you think about it in the most general sense, there is potential for conflict and stuff like that. So it's like two people, independently doing things, and there is potential for conflict. So,
I mean, I guess maybe one way to move forward here is to sort of define a priority. I mean, like if you tag a pod with various networks, the first one in the current proposal is the primary network, and so obviously that one has precedence, and we could just say that the list is ordered, and if there is a conflict somehow,
primary always wins type of thing. Okay.
Yeah, or maybe the second plugin wins over the third, but it's hard to figure that out. Because if
I think a cleaner way
is not doing the routing, then how do you enforce this?
I think a cleaner way of doing this would be just follow standard IP procedures and do longest prefix match. If you really want something to go down a specific interface, make sure it's got the addresses are longest prefix matched. And then the kernel will always do the right thing.
I'm not sure that is going to solve this problem. I mean, you can have longest prefix match, but then you could have the same prefix in two different networks.
Yeah.
Right?
Well, that's what I'm saying.
So the priority that Dan was referring to, that will solve this problem. It will actually resolve between two. If you're relying on the longest prefix, you're still leaving things to chance, right?
It solves that problem, but it brings up the problem of who actually enforces.
Exactly.
Exactly. Kubernetes itself isn't touching routes inside the pods, then we have to.
Well, no. I mean, so the interface spec itself goes inside the pod spec, right? It's going to say this is the attached network, and if you're going to add a priority to it, then the plugins have to honor it when they insert a route. Yeah, it's insert a route. It's going to honor that. So I think it'll work.
Okay. I mean, yeah, that would be acceptable for now.
Yeah, I mean, I think simpler is better if we're going to get anywhere on this, right? So let's try and trim out the stuff that we don't think is necessary for an MVP. So I would definitely argue for start with just an order list, longest prefix match, and don't misconfigure stuff.
Yeah. Is that sufficient to move forward, Judgy?
I think so. I think the rest of the things are like minor things. I think everything finally boils down to this issue, I think. I mean, there was this issue about whether you pass an argument. Okay, I just kept it as a generic placeholder. So I think you can probably, so let's say I attach a network and there is a way to pass an argument to the plugin from the pod spec. Does that break anything? I'm just trying to understand. I just wanted to keep that, again, from the point of view of not having to revisit this again. The idea is to cover as much as possible with what we're doing.
I think that's the reverse way to think about it, though. The kind of bar for modifying API objects and adding stuff to them has to be much higher than does it break anything.
No, that's okay. So the question is, we are not adding a new API object for that, right? I mean, you're just adding one option. So the question is, if I have an option to pass an OPEC, we already have ways to pass OPEC information via labels and stuff like that. even in pod spec, you can pass arguments to the application using opaque arguments. So I was just taking the same line here. So the idea is, like I was saying, again, following Tim's directive of trying to solve as many problems as possible without having to change this.
I think I know the comment you're talking about, and I responded earlier today. And I think annotations are the mechanism you're looking for here.
Yeah, I think I'd definitely go for annotations on the network spec.
Okay, so we can do that. So the point is that there are alternatives. So I think we can. I think the rest of the issues are all none of them are insurmountable. I think we'll move forward. If there's anything else, I think we can discuss it over email or in the document. I think this was the main issue. So I think we'll just take the approach that we agreed on. Okay. Okay, great.
Cool. So I think next steps then are probably updating the doc. Onto this discussion, people who have outstanding questions, could you, and myself included in a bunch of places,
sure.
either resolve the ones.
Yeah, it's much. Yeah, I think with this, convergence, it's much easier to answer those questions.
Yeah, I was just giving a call to action for anybody with outstanding questions to either resolve them if you feel they've been resolved, or
if I don't see them resolved in a day or two, I will move them to resolved, and then if you don't agree, you can reopen them. So that's this is general thing. So I'll wait for 2 days, and if I don't see issues resolved, I might mark them resolved, and if you don't feel offended that I resolve them, just reopen them and tell me you're wrong. Okay, that's fine.
Gotcha. Cool. So we have a couple more topics. Dan, you added a question about kubeproxy. You want to talk a bit about that?
Yeah, I was just kind of wondering, we've talked about kubeproxy on and off in this meeting for a while, and there are some issues, obviously, around IP tables and IP tables usage in kubeproxy performance, as well as cooperativeness. And so just kind of thinking about the future of kubeproxy, NF tables comes to mind because that's kind of the closest analog to IP tables. But I was kind of curious, what other technologies are people looking at for kubeproxy? Have you implemented your own kind of version of kubeproxy, or maybe a different way to phrase it? If you could do whatever you wanted with kubeproxy and rewrite it in some way or modify it in some way, would you use something else like eBPF or Splice or IPVS? Or are you happy with IP tables? So I was just kind of throwing that out there to the group.
Do you also have any opinions on X versus Y?
Yeah, my current thought is that to solve some of the problems with IP tables, contention, and performance, that NF tables is probably the clearest path forward because, like I said, it's the closest analog, and it does provide some of the things that are useful, like notifications when rules change. It also provides a much more granular way to change rules than replacing the entire world, which is the cause of some of the contention issues that we've seen. But NF tables may not quite be ready yet because it may not implement all the features of IP tables right now. But again, it seems like most things that kubeproxy currently does with IP tables could be converted over to NF tables fairly easily. Whereas something like eBPF or Splice or IPVF would probably be a very large rewrite of kubeproxy. And all of those have their kind of upsides and downsides. But I mean, personally, I haven't explored too much down the eBPF or IPVS or Splice path. I know Tim Hawken has some ideas about IPVS, and I've heard some stuff about eBPF here before, so I was kind of wondering if anybody in the call, for example, has explored using eBPF to do some of the things that kubeproxy does, if they have any opinions on that, or any of the other technologies, or something that's not on the list.
I have a question about this.
Sure.
So why is this a choice in some sense?
It's not necessarily a choice. It could be that there are parallel proxies. I mean, there's already the user space proxy and the IP tables proxy, and the Windows Kubernetes team is kind of writing their own proxy specifically for Windows, since obviously Windows doesn't do IP tables. So it's not necessarily an either-or choice, but it seems like there's probably not enough manpower behind kubeproxy already. And so attempting to expand the set of choices might not be the best thing unless people step up to maintain those going forward. But then also, there's kind of only right now one kubeproxy. Do we keep it as is and add something else and kind of deprecate kubeproxy, or do we, convert it over to something? I guess if that answers your question. I think one of the main issues is that, going forward, there are some clear limitations with IP tables. So is there a way that we could solve those limitations and make kubeproxy more flexible? And maybe that's through a different technology than IP tables. I know some people on this call have thought about this in the past because we've had discussions, I think, late last year and last fall about the future of kubeproxy. I was just wondering if there were any thoughts or updates. And if the answer to those questions is silence, that's also fine. We can go back and continue that discussion on the mailing list as well.
Yeah, I think it would be a good idea. Maybe we could sort of figure out kind of what a generic kube overlay requires and then go look at the technologies. For example, one thing is implementing services. Another is maybe implementing the overlay and so forth.
Yeah.
And then seeing how that slots. Because I think right now it's like very focused on, kubeproxy plus IP tables. And maybe it's hard to see that.
Yeah, definitely. That's something I think Tim brought up as well, that there's no really good document that says this is what is expected of a proxy for Kubernetes, including kubeproxy itself. So even if you were to write a separate proxy that was not kubeproxy, it's hard to know all the intricacies of what kubeproxy currently provides, and so whether or not your alternate proxy even meets those requirements. So I think that is a very good point. We do want to create a document that describes expectations of a proxy, because that'll help guide any forward progress and make sure that we don't regress in features as well. So we can take it up on the list, given that we have like 4 minutes left. So thanks.
Yeah, let's do that. So there are 2 things left. Chris, do you think the DNS per namespace update fits in 4 minutes?
Probably not if there's a lot of opinions.
Yeah.
I think our major quibble about this before was along the lines of namespace is maybe too short-sighted as far as limiting each namespace to only be able to contact things in its namespace and not information leak. And there was a plan potentially to introduce an idea of like an organization thing which wraps together multiple namespaces. But when I brought that up to SIG auth, it was kind of like this is going to be a great thing, but it's probably going to sit in proposal phase for quite a bit. So I was wondering if anyone had any thoughts on maybe an interim step to get to there.
Yeah. So why don't we either push that discussion to the mailing list because it sounds like a larger one, or until the next call because I don't think it's going to happen in 3 minutes.
Yeah, I'll bring it up on the mailing list again.
Cool. And then the last thing that should fit in 3 minutes is Berlin is fast approaching. I know a bunch of people said they're going to be there. We have booked 2 slots for the SIG for in-person meetups. So we should probably only have 1, unless we think we need 4 hours to talk. Not sure if everybody's been following that discussion. Does anybody have a preference on which slot? I booked 1, and Brian has booked 1. before we cancel one, and make sure we're not canceling the one that more people can make.
What were the time slots again?
Yeah. Sorry.
I think it's 2 to 4 and 4 to 6.
Yeah, that sounds about right. I think there were some people who were not getting in until earlier, like mid-afternoon.
Your sound is really hard for me to hear. I don't know if everyone else is getting that.
Is that me?
Yeah,
I can also hear it very weirdly.
Oh, sorry.
It was okay before.
Is that any better?
Perfect.
much better.
Cool. Don't know what happened there. Yeah, I had thought some people said that they were getting in kind of mid-afternoon, or at least wanted to sleep until mid-afternoon. But if nobody has any preference, shall we flip a coin?
Well, there was one vote in the mailing list for the later.
Right. Cool. So I guess if one beats none then.
Did you book your room through the CNCF events people?
I booked it just through that spreadsheet, which I thought was already all reserved stuff, according to the email I got from I forget exactly from who, but they sent around an email to SIG leads saying, they booked these rooms for on-site stuff and put your name down for one, if you'd like.
Okay, I wasn't party to that. I filled in a form. Oh well. It's actually still not. Well, the only thing it says in the public spreadsheet is March 28 late afternoon or early evening.
Well, let me check in with whoever sent that around and see what the deal is with those slots. And Brian, I'll just reach out to you.
I'll hang on to my booking. They haven't taken a credit card or anything. So.
Okay, cool. Yeah, it sounds like there's minor preference for the later one, but I'll just double check that we actually have that one before we cancel yours.
Yeah, send me an email.
Cool.
Slack me, whatever.
All right, that's our time for today. So
thank you.
It's 2 weeks. What's 2 weeks from now? That'll probably be in person, right?
2 weeks is the 23rd.
Right. So let's keep on for the 23rd then.
And the meeting's in the US time zone, so for me it's an hour earlier.
Which meeting?
This one.
Yes.
It stays at the same time in the US because they're different daylight savings times. It moves for people who are in Europe.
Yeah. Indeed. Cool. All right. Thanks, everybody.
Bye.
Bye.